Ready?
Yep.
Oh no, that's not working. Okay. Sorry, explorers. We'll try that again in just a second. Welcome back. My name is Catherine, and this is Physics Week. I am really excited to be doing this lesson with you today. It's one of my absolute favorites. We are going to be making bottled rockets. I'm going to show you some demonstrations with the bottle rockets we used here in the lab that take a little more skill, and then after we talk about how that works, we're going to go outside and we're going to show you how to make rockets that you can do at home using only baking soda and vinegar. So let's get started. Physics is all about motion, right? So the laws of motion, how things move, otherwise known as Newton's laws of motion, we have 3 of them. And I want to go over the first one first. So things at rest keep resting, and things that are moving keep moving unless another force acts upon them. So for example, here is a demonstration of Newton's first law. Nothing is happening. This bottle is not going to move because it is already at rest unless some other force acts upon it. Can you think of anybody in your family who that when they are resting, sitting on the couch playing on their phone maybe, is very difficult to get moving? They have a lot of inertia. Or maybe you have somebody in your house, maybe it's even you, who once they get running, playing around outside, they do not want to stop. So, Newton's first law. Things are going to keep doing what they are doing until we act upon them, some force. So, let's move on to number 2. How quickly things change speed depends on how big they are and how much force you use. It's going to be a lot easier to speed up a baseball than it is to speed up, say, an elephant. One of them is bigger than the other, so it takes more force to get it to move quickly. We write that mathematically with the formula F equals ma. Force equals mass times acceleration. You can think of this too. It is going to, a lot more force is going to act upon something if it is more massive. Number 3, if you push, you're going to be pushed back. If you pull, something's going to pull against you. We state this as for every action, there is an equal and opposite reaction. So let's show you how a few of those things work. I already showed you law number 1. Something at rest is going to stay at rest, and something that's moving is going to stay moving until another force acts upon it, an outside force. So let's try my experiment again. That didn't work quite the first time. We're going to see if we can get it to move. Are you ready? 3, 2, 1. Much more successful. And you'll notice that that rocket kept moving until it hit a wall, until another force acted upon it. I'll leave that one right over there. And let's talk about that second law. So remember, I said that how fast something moves depends on how massive it is, how much stuff makes it up. So let's try it with these 2 bottles here. As you can see, I have a very small bottle and I have a very large bottle. And this, we can probably predict, is going to do the same thing as before. Let's see if we can get it to move, huh? I'm going to spray quite a lot there. All right. 3, 2, 1. That one went very far, very fast. Let's see if this one does the same thing. Not so much. It did move because we had some force upon it, but because it was so much more massive, it didn't move quite as quickly. It didn't accelerate the way the other one did. And of course, the third law is kind of intuitive. I think I'm going to let you guess how it works here. So remember I said for every action, there is an equal and opposite reaction. Now my bottles here are moving because as we have that fire, that combustion reaction inside, the gases themselves expand and push against the bottle themselves. So I bet you can guess which direction these bottles are going to go. For this bottle right here, which direction is the fire going to come out of? I have a small hole at the end. That's right, the fire is going to go that way. So that means where's the bottle going to go? That's right, it's going to go in the opposite direction. So if we have a force coming out this way for this bottle, then the bottle should move that way. Right, equal and opposite. Let's do one last one before we show you how to do the other type of rockets. 3, 2, 1. That was a massive one. Good thing we have our handy fire extinguisher just in case. Now, for this next experiment that we're going to show you, you will need safety goggles. So go ahead and grab those and let's go outside. Okay, so where we are right now is actually the center of learning here at MOSI. We have a lot of our weekend activities, weekend camps, and even our summer camps out here. So let me show you real quick how you can make a model at home that's a little less volatile, I should say, than our rockets that we just did inside. What you're gonna need is baking soda, vinegar. You are going to need some sort of bottle. I use these little ones here, but you can use any bottle that you have at home. And you are going to need some corks. Maybe ask your parents if they have any of these lying around. Some other tools you might need include a funnel, just to make things easier. I also have a measuring cup and some measuring scoops. And some paper, of course. That's gonna help us with the baking soda in just a bit. And what you're gonna wanna do is get something like popsicle sticks, or if you don't have those, pencils, pens, anything straight and even that you can duct tape around the outside of your bottle like so. And when you do that, you should try to be very careful that as best as you can, the bottoms of them are even so that it'll stand up. Mine is a little bit wobbly, that's okay. Okay, just like that. Perfect. Now, I'm gonna show you what you need here. You can just test this out if you want, see if you can get it to work. If you're feeling a little more ambitious, you can also run an experiment. You can see how much vinegar to baking soda you need to get your rocket to go as high as possible. I am going to start off using about half a cup of vinegar. Whoops, no worries there. And you can go almost all the way up to 1 cup of vinegar, but that's about as high as I would go. Anything more than that, and it just becomes kind of difficult to handle. Now, as far as baking soda goes, I would recommend using, to start off with, about 1/4 cup of baking soda. Now, this is quite a lot of baking soda, and the only reason I suggest using so much is I have a feeling some of it is gonna get a little lost as you pour it into the bottle, and that is okay. All right, so we're gonna try to shoot off our rockets. Bear with me because it is a tricky process and you might have to do it multiple times. We never know quite what's gonna happen in science, so that is again why I'm wearing my safety goggles. Oh, and one last tip. This activity is very good if you have a second person to help you. If you have a little brother or sister or an older brother or sister, somebody in your family who can give you a hand, this is gonna be twice as easy. All right, I'm gonna come around to this side here. You can step back so you don't get splashed. And I'm gonna use my funnel here to pour in the vinegar. Another thing you might want to consider if you are doing this activity is the direction of the wind. So for me right now, the wind is going in this direction, so I can probably predict that as my bottle shoots up, it's going to go that way. So just kind of be aware, make sure you don't have it land in a neighbor's yard or something like that. Okay. Now, when you do this, there's 3 steps. You're going to dump it, cork it, Ready? Dump it, cork it, flip it, step back. Nice. Woo! That was pretty good. Yours might not shoot off on the first time, and that's okay. We're gonna try it again. Is anybody watching right now who wants to give me a suggestion of maybe how much more vinegar I should put in? Should I put in a little less? Should I put in a little more? My guess is putting in more should make it go a little bit higher. What do you think? Let's try. This time, I'm going to put in an entire cup of vinegar. Now remember, the more vinegar you put in, the quicker you're gonna have to be when you cork that bottle. So, doing it again. All right. And I'm using regular printer paper here. The stiffer the paper you have, I find it's a little easier, so I fold mine in half. And again, because I want to keep as many variables the same as possible, I am only going to use the same amount of baking soda we used last time, which was 1/4 cup. Alrighty. I've got my cork, got my baking soda, feeling the direction of the wind. Okay. 3, 2, 1. Dump it, cork it, flip it. Woo! Too slow. So that's what happens if it takes too long. And like I said, the more vinegar you put in, the trickier that's going to be to do. No worries. And if it gets on you, it's just baking soda and vinegar. It cleans right out. All right, let's try it one more time. This time, instead of maybe a whole cup, I'm just gonna put in 2/3 cup. Make it a little easier on myself. Hopefully that will give me a little bit more time. Okay. And as always, if you have any questions or comments or things you'd like to see in the future, go ahead and put those in the comments below. All right, again, same amount of baking soda. Okay. And it's important that you get a cork that kind of fits your bottle really well. Some of them are a little too small, so test it out before you do it. Okay, here we go. Let's see. I need one more successful launch before I'll be happy. Ready? 3, 2, 1. Dump it. Woo! Cork it. Flip it. Woohoo! Success! Not bad. All right. Go ahead and try it out at home by yourself or with a sibling. Let us know how it goes. Thank you for watching again. As always, keep discovering.